Okay, so now we're almost done. We just need to do the regression analysis, which is actually the important thing in a way to test if there is a statistical relationship which is higher than just the correlation. So to do that test, click on Analyze, and then go to Regression, and then Linear. Click there. And then you will get this table, this pop-up. So what you need to do is to start with the dependent variable. In this case, we have the global mindset. And go click Add here, global mindset. And then we need to add an independent variable. For now, what I will do is that I will add collectivism. I will assume that I am studying global mindset and collectivism. Just that. Add it to independent, and then go to statistics. Don't click OK. Go to statistics, and then you will get this thing. And click on collinearity test, collinearity diagnostic, because we will test for multicollinearity. Click OK, and then click OK again. And you will get this. So the first thing that we need to check, because now we have an order, we need to check for several things. The first thing that we need to check is for the model fit. That if this value is more than 0.1, nothing works. We need to do another model. This model cannot be interpreted at all. That's the conclusion. Cannot be interpreted, and next model, because it literally doesn't work. And how do you test? How do you find if a model works or not? This model fit is in this number in here. So if this number is more than 0.1, your model doesn't work. In this case, it's 0.01, so that's good. The model can be interpreted, the model works. So we passed the first thing, the model fit. That's the very first thing that we need to discuss. The second thing is the R square. The R square tells you how much of the variance of the dependent variable, the global mindset, is explained by the model. We have a very low R square is 2.5%. So that means that the variance of the global mindset is only explained by 2.5%, which is very low. But that's fine. Why is the case? Because we only have one variable. It's very obvious that it will not really explain a lot. That is actually the reason why we have control variables. You will see in the next models. With more controls, this R square will improve. Usually, we are more suspicious of high R squares than with low R squares. In engineering, R square is the most important thing because you don't want variations. Imagine that you have a model where you can only explain what will happen with 2.5%, or that you don't understand what happens. That's very bad for engineering. In social sciences, that's actually impossible to have a very good model in terms of R square, because socially and psychologically we're complex. So if we manage to have a very high R square, like 90% to 95%, that's suspicious, because is our model really that good that we can actually explain 95% of our behavior with this model? That is usually never the case. So we usually say that 5%, like 0.05, it's like minimum. I think we can do an exception in here. We can say like it's low, but okay, let's move forward. And we usually say like 8.8% is too much, and then we need to be careful. But for now, let's just make an exception, and let's say like 2.5% is still fine. We move forward. The next point that we need to discuss is this collinearity here, the BIF statistics of the collinearity test, this one here. So in here, we want to have hopefully less than 4. More than 4 means that we have a problem of multicollinearity. Maybe we are measuring the right thing twice. Like, for example, usually age and experience, they correlate a lot together, and they usually have a high BIF value. But let's wait, because in here, of course, we cannot have that, because we only have one variable. So we cannot have multicollinearity. We only have one variable. So we pass test number 3, the third kind of gatekeep. And the number 4, the next one, and it's just the final one, is a variable specific test. And it is in here, in the significance. The significance that we seek is less than 0.1. Like here, in this case, our significance is 0.01. That is good. That means that that collectivism is significantly positively related to global mindset. Why is it significant? Because we have a standardized beta that is positive. You have to also read this. If this will be negative, then the relationship is negative, right? So this is where you actually test your hypothesis. If your hypothesis was that there was a positive relationship between collectivism and global mindset, all of these numbers tells you that you can accept that hypothesis, that you support that hypothesis. That's how you actually say it, support. Kind of a quick summary. The model fit is significantly, statistically significant because it's less than 0.1. Good. The R square is not suspiciously high. We're making an exemption in there because it's a bit low, but it's okay. So R square, we also pass it. The next thing is that we don't have multicollinearity problem. Of course not, because we only have one variable. And finally, the variable is significant and positive. So we support our hypothesis. And that will be model number one, because we will do more than one model. Let's do the next model. Go again to linear regression. And now what you need to do is to add the control variables that we have, gender, age, all of this in here. And then click OK, because the statistics is saved with collinearity diagnostic, it works, and then click OK. So we need to do the same thing to check, like we did before, if it is okay, we're going to do now. So first, the significance, we pass it. It's 0.07, so it's less than 0.1. That's good. So first test, we passed it. Second test with the R square, now we are at 5%, so we also passed it. The next thing, multicollinearity. Actually, we don't really have a problem. I was a bit skeptical because I felt like maybe age would be maybe too close with level or with, I don't know, with something maybe, but not really. So there is no multicollinearity issue. If there was, it would be 4. And actually, how you fix it, you just, again, maybe the ones that are too high, you need to remove one. Like generally, age and experience, they are maybe too close together. So test 1, pass. Test 2, pass. Test 3, pass. And the last one, we don't really care for the significance of the control variables. Why we use control variables was only to increase the R square. That's it, only to increase this. So what we actually care is about collectivism and its significant. Is significant, 0.01 is still less than 0.1, and the standard coefficient is also positive. So again, even in model 2, we can support our hypothesis. So model 1 support, model 2 support. Let's move to the next one. We still need to do one more model. So what we are going to do in here in this course is that we are going to borrow one of the other variables from other groups and include it as if it is a control variable. So let's say I will include biospheric values. I will include it in here. For this group who is doing collectivism, biospheric will be just a control, right? And this is model number 3. And we do the same. Significance, fine, it works. R square, you look at this, it improved a lot. So it's always like that. More controls, you will have a higher R square. It's just that your model is more robust. So you have more explanatory power of the variance of the dependent variable with more variables. We also don't have a multicollinearity problem. That's also you need to check. So the 3 things we check. And we finally have collectivism that is also significant, is less than 0.1. We also have biospheric values significant, but we don't really need to discuss that because we don't have a hypothesis for that. We don't need to test anything because we don't have that hypothesis. This group doesn't have that. This group only has collectivism. And finally, we also have positive standard coefficient. So also in model 3, we support the hypothesis. So collectivism will we say we fully support the hypothesis because in the three models you support and the three models are valid. There could be combinations. The opposite is that maybe it is not significant in any of these models, like maybe something like this 0.58, for example, age. If for some reason we had a hypothesis of age has a relationship with the global mindset, it will be fully not support, fully reject. Yeah, because not in any model it works, right? No, it doesn't. But in the first one it's not, but in the others it doesn't work. So in age will be fully not support. It could be the case that maybe in other groups, maybe model 1 you support, but 2 you don't support, and 3 you support. Then you can say that you partially support because you have like one model that says no and another says yes. So the final conclusion is partial support. That's why generally we like to have like odd number of models. So then you can have full support if if everything works, and then partial, but usually you don't want to have like a draw, like 2 and 2. That's why you want to have three models. So you have 2 and 1 or 1 and 2. So partial support or partial reject. And those are the combinations that you can have. What happens if this doesn't work in one of the models? You can just remove that one. You cannot interpret at all. It's not that it doesn't work and you reject. No, you cannot neither reject or you cannot support. So that could be a bit problematic in the sense of having odd number of models, because maybe if you plan for three and one model doesn't work, then you have only two. But that could happen. But don't make the mistake that if this is not significant and then you reject the hypothesis. No, you cannot even reject, you cannot do anything. So that's kind of the conclusion. So now we finish the analysis. We still have the lecture on reporting quantitative data, where we will come back to the interpretation of the data because we need to put it in a nice way and we also need to write a few paragraphs about it. So that will be clarified. But hopefully these videos are useful for you when you go and do it again, maybe for this assignment or maybe in your dissertation, or maybe in the future in something else. Then you can use this as like instructions on how to use the survey data and SPSS for the statistical analysis. So that's